Okay, so we're going to start. Thank you very much for being here. Hi, everybody. I'm Lilia Sfepsi, and I'm co-chair of the conference AI and Big Data with Mrs. Fatma Siela, who is here with me also. We are really happy to see you today and to accompany you in this very particular conference, which is online, but I think we get used to it. And we're really happy to have our keynote speaker, Professor Dario Colazzo, who will be presenting his speech, which is called Inference de schéma JSON via Spark. So, Mr. Dario, you can start whenever you're ready. Thank you very much.
Thank you very much. And so I'm Dario Colazzo. I am professor at l'AMSADE University Paris Dauphine PSL Research University, and this is joint work with colleagues in Paris, I'm in Bazzi, and in Italy, Giorgio and Carlo. And the work I'm going to present is about schema inference for massive JSON dataset. I will quickly present you JSON schema, and I will tell you why it is important to have a schema and why we need to infer this schema in many cases. So concerning the questions, there is a session chair who is going to manage this. She will decide when it's question time and questions are allowed. So I will talk to you about JSON and JSON schema essentially by means of example, and then I will focus about our contribution, and I will compare our contribution to another mainstream contribution, which is the contribution proposed currently in Spark SQL. We used Spark to implement our approach because we need parallelism and distribution in order to cope with high volume of dataset. And then I will conclude with some closing remarks. So what is JSON? JSON is a data format, as I was telling before, which relies on expressing records of key value pairs, like you can see here, and arrays. And the nice aspect of JSON is that you can nest as you like arrays into records and vice versa. And of course, you have base values as well, like booleans, numbers, strings, and the null constant. So I will skip these details. You can read, but I think that the most interesting part is after. So in the basic values, as I have told you, are essentially strings, numbers, booleans, and the null constant. And what is very important in JSON is this possibility to express records by means of this notation with curly brackets, and you put in this in between the curly brackets all the field names on the left-hand side and the value for each field name that you have. And you can see that the value can be different. In this case, you don't have nesting and you have unicity. You don't have repeated field names here. Can you see the cursor here moving? Yes? Okay, I hope so.
No, we don't.
So you don't see. If I do this,
yeah.
Okay, so perfect. So actually, those labels here are required to be, in practice, they are very often unique, but the standard allows you to have repeated labels, but this is very bad practice. You can have some unexpected behavior of several applications. So we will assume that these labels are unique. Arrays are noted with this notation, with square brackets. And in this example, which I will use frequently in my presentation, you have a record where a value bound to a field name is an array containing inside in turn one record. So, and of course, you can have simple arrays of base values. So this example is useful to be convinced about the high flexibility of JSON. And this is one of the reasons why it's highly used in practice. Sometimes it replaces XML, which is much more powerful, but much more, but let's say more complex than JSON. So JSON is widely used today, essentially for data exchange purposes and for data storage purposes. You have several systems dedicated to JSON data management, and whenever you need to download an external data source, it's very likely that this data source is available also in the JSON format. There are several public data collections available in JSON. In this talk, I will use several times JSON data that we have been able to crawl by using a web API, and these are data related to New York Times, to articles. Okay, so a few words about this particular data set. So why we focused on the New York Times data set? Actually, it's because we were looking for interesting data sets to be used in benchmarking our approaches. And we have found this data set, which is very interesting. It's interesting because objects can be nested in this data set, and there is some high irregularity. So the collections is not regular, and so it's very interesting to use this data set in order to benchmark our technique, how our technique deal with variability in the structure when you have a data collection. So this is essentially the main reason. So what is JSON schema? And first of all, what is a schema for a database? So I think every one of you knows what is a schema. It's a specification of the structure of a data collection plus some integrity constraints. And we all know that schemas are of vital importance. Without schemas, you cannot go too far in data processing. They are used to validate your queries, to enable query optimizations, etc., etc. But whenever you have a schema, you need the tools to efficiently checking that, for instance, documents dataset are valid with respect to the schema. And we can say that the schema language is good if you have at least these properties. So first of all, schemas should be easy to define, read, and understand. Otherwise, it's difficult to use your schema language. You should be able to have the possibility to express complex properties, and the schema language should be so that efficient algorithm can be defined in order to check crucial properties, like, for instance, checking that the schema is consistent. There is at least one instance, checking that two schemas are included one in the other, and checking that, for instance, if you have queries, those queries are correct with respect to the schema. So these are just a few main research problems for schema languages that have been solved for many existing schema languages, but for JSON schema, these problems are still under investigation, and we are working on this. So we are focusing on a particular JSON schema language, which is called JSON schema. It's, let's say, the standard. But there are other proposals that are used in several other contexts. So let's see the main mechanisms of this schema language. So it's a language to describe collection, properties of collection of JSON value. And the main mechanism that you have is the one used for describing object. So the syntax is this one. With this syntax, with this grammar, you say that you are describing an object, and the object has the properties that you declare here. So more concretely, let's see an example here. Here we are saying that we are describing an object whose fields are named as A and B. But we have to pay attention, because there is a very particular semantics of JSON schema. This declaration says that an object satisfies the schema in the following case. If the object has an A field, then its type is a string, okay? And if the object has a B field, then its type is a string. But this schema here also allows for objects having a D field, an H field. So essentially, we are saying whenever there is an A, it's a string, and similarly for B. So it's very flexible, and this aspect needs to be taken into account in order to fully understand the language. If you want to enforce that both A and B are mandatory, then you have to add this clause here saying that both A and B are mandatory, and you also need to add this clause here if you want to exclude whatever other kind of field names in the objects you are describing. So it's a very powerful and flexible schema language. So let's see another example related to coming from the New York Times dataset. For instance, concerning the byline information of article, we realized that essentially you have three possible cases. So when you examine the New York Times data collection, this field can either be null or can be an object where there is a person field, which is an empty array, if the organization field is present. Otherwise, person is not an empty array, but it's an array of records with fields, first names, second names, etc., etc. So in order to describe fields, you need something which is able to define union types, alternatives, either this one or this one. And in JSON schema, you have this any of. The any of means one of the following alternatives. And essentially here we are saying that we have, okay, of course, byline is used inside some object. And here is the definition, the schema for byline. The type of byline is either null, either a schema defined here or a schema defined here. So you can say that in JSON schema, I can put definitions, preliminary definitions, by introducing names and the definitions, and then whenever I need those definitions, I can use this path to say I want the schema associated to S1 available to the at this path that can be traversed. First, I have to start from the root, then I have to traverse the first definitions, and then I have to traverse the field S1, and here I have the case defining this first case, and similarly for the second case. So the first case, let's recall that it's the case where the byline record is a record with essentially four fields. They are all mandatory, and you don't want any other field. The fields are contributor, organization, original, and person. And as we have said before, in this case, person is an empty array. So you say this by saying that the person is an array, and at most you can have 0 items. So this is a particular way to say that the array must be there, but must be empty. This is because in this case, the byline is an organization, is not a person. So the other case for S2 is the case in which you have a contributor for the byline, original, and then you have persons, okay? Persons who have participated to the writing of this article. You say that this is an array, that at least there is one person, and then the persons are defined, each person as a record with first name, last name, other aspects like, for instance, organization. And then you have the usual additional properties and required. So this is a very nice example illustrating that essentially you can have nesting, you can have union types, you can express alternative types, you can define and then refer to definitions, etc., etc. And that also expresses the fact that you can have irregularity in the definition of properties. So just some few words for JSON schema. It's widely used today, also because in some data processing setting, you must use a JSON schema. Otherwise, you cannot process your data. I will outline this after. There is some interesting study done for JSON schema, but much needs to be done in order to understand the semantics of JSON schema, and also to compare JSON schema to alternatives, like, for instance, Joy, JSound, and Mongoose. Those are other possibilities to express JSON schemas, which are not used as frequently as a JSON schema, but they have some important use cases. So I invite you to check the web in order to find information about these languages. But essentially, JSON schema is the most impactful one that you have today. So let's start now with our work, what we have done in the last, let's say, 3 years. So this is something that we have started in 2017, and now we have behind us several papers published about the problem and the results I'm going to show you. So what we have done is to develop a schema inference technique for schemaless JSON data. What is schemaless JSON data? It's JSON data that you can find somewhere which has no schema, that comes without a schema. Is this frequent? Yes. In very frequent cases, you don't have a schema together with your JSON data, but we know that we need the schemas. The schemas is crucial for the analyst in order to explore the data, to develop algorithms which are correct and correctly process and navigate through the data. And also the system, the data management system needs the schema in order to perform and to enable query optimizations, in particular when the data is massive. We have structured and semi-structured data with a variability. So this is one of the reasons why you really need the schema. If you have a semi-structured data collection, meaning that you have a collection of records and the structure it's not fixed a priori, that could change, you really need the schema in order to be able to see in a succinct description what is the global structure of your data, where is variability, in which way the data can change the structure, etc., etc. If you don't have the schema, the only possibility that you have is to extract a sample and explore by hand, by eyes, your sample, but this is error prone. You can ignore an important part of your data structure. So having a tool for schema inference ensures that you have a very global description. So our approaches are fully formalized in the sense that we have a very rigorous mathematical formal specification of our setting and our algorithms, and we have mathematically proved that important properties hold for our approach. The other aspect is that we can say that the ideas behind our approach are simple and effective and useful in practice. But of course, as I will show you, we didn't explore all the alternatives, and several alternatives remain to be explored. And the other aspect which is interesting is that our algorithm can be implemented in a MapReduce fashion by using, for instance, Spark, which implements MapReduce. Another nice aspect of our approach is that it is parametric. The user can tune the system in order to guide the system towards a particular schema to infer. Okay, I will show you this by means of example. So just to summarize, the setting is the following. You have a lot of data out there. You want to process them for exploration, data analysis, machine learning. You don't know what is the structure of data, or you just have a partial vision, a partial knowledge of the structure. And by means of our tool, you can display, you can have a schema which is more or less succinct, depending on the parameters that you set, and this allows you to have a global, rather precise vision of the structure. And with this, you can safely define your queries, your code for processing, and the system can enable optimization. And it's also extensible. So you will find the details in those papers for which you have the references. So let's introduce our notation for schemas. Actually, it's not that different from that we have seen before, but it's more abstract in order to develop formal reasoning. Otherwise, you cannot go too far if you want to formalize your algorithm. So these are the values. So records, arrays, and base values. Essentially, at the type level, our schema language, we have used a schema language which is a part of JSON schema, which is not as powerful as JSON schema. It's a very interesting, a very expressive subpart of JSON schema. So essentially, we have a type for base values, the bool type, the num type, the string type, and we have a schema type for objects. So essentially, with this type, we say that we are describing objects having as fields L1, Ln, and then the type of each field is defined by a couple. So on one side, you have the type of the field, and you have this qualifier. The qualifier says whether the field is mandatory or optional. So this is very important if you want to deal with the variability, semi-structured data. And then you have a type for arrays. We have a schema, an array type, saying that concerning your array, you can say what is the type of a generic element, and then you can have 0 or more elements of that fixed type. So we have to pay attention to the fact that we have this any of union type here, which essentially says which describes values having either this type or the types are listed here or this type here. So if you put this type inside an array, you are describing an array whether each element can be one of the type mentioned in this union type. So this is very useful. Union types are useful to describe variability in the structure. Otherwise, you cannot do a lot of semi-structured data. Okay, so let's illustrate our idea. So essentially, what happens in practice is that you have a list of collection, a sequence of collection, and it's not true that that objects belonging to this collection share the same structure. Actually, it's very often the contrary. There is some variability. So imagine that you have this first object here, a second one here, a third object here, and a fourth object here. So as you can see, those objects share something, the presence of an A field and a B field, but you have some variability. Here you have a CD, while you don't have here, you have E and F instead. This is JSON notation simplified. I'm not using quotes, I'm not using a lot of JSON stuff in order to simplify the presentation. So what is a schema? What is a possible schema description of this collection? So one possibility is to say that this collection is described by this schema. This schema says that I have a sequence of records. Each record must have a field of integer type, must have a field B, whose type is either one integer or one string. We can say here, we can see here that B is always present, but here is a number, and here is a string. So I have to use union by means of this plus in order to model this variability. And then I have C. C, it's not always present. So first of all, I have to say that C can be either an integer or a string, as indicated in the data collection. And then I have to say that it is optional. And it's not always the case that I have C. Similar for D, and similarly for E and F. Okay, but this schema here, it's somewhat an over-approximation of the dataset because you can also have records with A, B, C, D, E, and F, while it's never the case in your data. So it's not that precise description of your dataset. But this schema here says about what are the fields that you have, and each field, what is the type. This is already very useful in practice. We could have this other possibility. We could say, okay, here I have this structure, here I have this structure here, okay? And this schema here essentially describes all the records having A and B and C and D, and this branch here describes the remaining records with the blue part here. So this is more precise. Never in this schema you can have the coexistence of C and E. There is another possibility, actually. You can have three schemas put in union. You can have this branch here say that C is an integer, this branch here say that C is a string. So essentially these two branches come from this branch here, generate these two branches here, and then I keep this branch here as it is. Okay, so this is another more precise schema. So what is the goal, the takeaway of this slide? The takeaway of this slide is that due to irregularity on your data collection, you don't have a unique way of expressing a schema. You can have a different way, and you need to define what are those possible ways and algorithms to describe this. So what we have done is that we let the analyst decide the degree of precision by fixing a parameter, and this parameter is an equivalence relation. Essentially, what we do during schema inference is that we merge record types. And by using this first approach, relying on an equivalence called the k-equivalence, essentially we say every record is similar, is equivalent to the other one. According to this k-equivalence here, we have defined this equivalence. So we merge, we fuse every record description, and we have this first possibility here, which is not that precise. But on the other side, you have a global description at the field level. You list all the fields and the field and the type of each field. You can be more precise if the user opts for the L equivalence rule in order to decide when two record types need to be merged. And essentially, this rule is very simple. It says that two record types are merged into only one, only when they have the same fields. If there is at least one field differing the record types, you don't merge them. So essentially, we infer a type for this, we infer a type for this in a map phase, like I will say, and then in a reduced phase, we build this type here. But on the other side, we don't mix these values with this because they don't have similar fields. So we have this second branch here. Okay, so this is something that we have considered as possible solutions, but there are several other possibilities you can think of. So we have implemented all of this. We have formalized. We have proved. Formal properties, and we have implemented this in MapReduce. How the MapReduce algorithm works? Essentially, the MapReduce algorithm is let's say, rather simple once you have formalized things. Essentially, you have a map phase in which each record in the collection is mapped, this is the map phase, of course, is mapped to a record type. So you have a type for this, saying that A is an integer, B is an integer, etc., etc. You have a type for each record. Then you have a phase in which you put together records having being equivalent according to the parameter you have fixed. Okay, and once you have done this in the shuffle and sort phase, then the reduce function merges the equivalent records and produces one possible alternative in the final union type. So the mapper reduce model is very useful to implement this approach. We didn't use MapReduce Hadoop in the original version, but we used Spark, allowing you to implement MapReduce data flows in a more efficient and more agile way. So what we have found is that our approach is simple to understand for the user, so that he can decide what is the best parameter fitting her needs. It's parametric, so it's flexible, but at the same time is somewhat too inflexible. Why? Because actually in practice, you want something more flexible. Let me explain this by means of an example. Without giving you many details, imagine that you have run our system on the New York Times dataset, and you end up with this schema here, saying that the byline field essentially as a record type, where you have organization, which is optional. You have original, which is mandatory. You don't have this optional here, and you have a person with all those optional fields. Okay, this plus K here means that the user has decided to use the K equivalents in order to fuse the schemas. What happens in practice is that for some parts of the data, you want less precision in the schema. And for some parts, you want much more precision. For instance, you can ask yourself, here I have a lot of content, but I don't know what are the constraints relating those parts. Is it true that actually FN always appears together with the LN or not? So what you could do is to say, okay, I want in some parts of the data, I want to use the K-based equivalence. I don't need too much precision. In some part, I use the L-based. So I want to mix the presence of K and L equivalents in the schema inferred. And just to be more precise, for instance, you can say, I want the schema where I don't want too much information about that part, but so I use the K equivalents for that region. But concerning person, I want the highest precision. Okay, and I can discover several interesting things. I can discover that sometimes you just have first names, sometimes you have first names with this other field here, and etc., etc. So those are all the possible shapes that is in the data. In your 20 terabytes of data, for instance, you just have this very limited number of shapes, and that could be very useful to code your algorithms without surprises. So what we have done in a second step is that we have defined the system, allowing the user to say, okay, you can use K and L equivalents, but at the same time in different regions of the data. So essentially, we have defined a family of approaches. We have fully formalized everything. Our approaches are parametric and can be parallelized by means of MapReduce, and are available on the papers. And we have a demonstration. We have recently given a demonstration also at DBT, so the tool is available if you want to play with this. So just let me finish with some remarks about Spark. Spark does schema inference as well for the SQL extension. But there are differences with respect to our approach. So first of all, let me mention that we are not the only one working with this problem. As I've told you, being able to infer a schema for a JSON schema, not having a schema initially, is crucial. So already Spark has worked on this. MongoDB, another very frequently used system to manipulate the JSON schema, has worked with this aspect, and Couchbase as well. But they all have some limitations with respect to our approach. Let's focus on Spark SQL. So Spark today, if you don't know Spark, it's a system very frequently used to process very large data collection by relying on MapReduce. And essentially has a lot of collections. The data processing is for analytics, SQL, but also for machine learning, deep learning, etc., etc. So it's it's used for several purposes. It's not tailored for one particular class of tasks. You have a lot of JSON data out there to process with Spark, and you need the schema in order to define your Spark code to process the data, in order to know what field to select and to manipulate in your algorithm, and what is the nesting, etc., etc. But also some optimization techniques need the schema. For instance, if you want to use the Parquet optimized internal representation of JSON, you need the schema. So actually, what happens with Spark is that either you provide the schema, you define your schema, or the system, Spark infers the schema by itself. So let me skip this formal stuff here and go directly to one example. Essentially, one particular aspect of Spark inference approach is that for Spark, every field is optional. So this is already a difference with respect to our approach. We analyze the data and we determine what is mandatory and what is optional. So, but in any case, if Spark infers each field by saying that this is optional, there is this third argument here, you can modify your schema and say, okay, wait, actually this original field here is not optional, it's mandatory, and I will set by hand this parameter. So you can always have some intervention. So what is, so actually Spark does a good job for schema inference. If you have, for instance, those two records with the different representation for the person part, for instance, here, Spark realizes that here you have an empty array, here you have an array with something, and in this case, since the type of person is always the same, Spark performs some fusion and does something similar to us, but with this particularity of the fact that everything is optional. The problem comes when you have very different objects. So imagine that not only you have those two records, but you have this strange record here for which you don't have any information. So in this case, Spark gets stuck. Actually, in this particular case, you have that here you have, for byline, you have an object here. For byline, you have an object here, but for byline, you have an array here. In this case, Spark does something very not very precise, and essentially says that byline is a string. So Spark gives up to describe the structure and say, this is a piece of string, please, if you want to analyze, go ahead, look inside and define your script, but at the schema level, I cannot tell you more. While in our case, we do something very precise. We say that byline is either an array or an object having those kind of structure, and in particular, we can tune the system with our parameters. So Spark does something that works well in practice, but this is something that could be optimized. And another aspect that is important to know is that Spark samples the data. It performs a schema inference on a sample of the data, but of course you can ask Spark to do the inference on the totality of the data set, but then you give up to performances. Okay, so closing remarks. There are several aspects to be explored. First of all, it's very interesting to analyze the user needs and then to guide the schema inference so that the schema inference could be adapted to the particular needs of the user. We can also put values in the schemas, for instance, saying that the field has 3 possible string values. This is something that we haven't done for the moment. And another interesting aspect is to deal with not only one collection, but several collections in data lakes. And data lakes today are very frequently used. You have the Delta extension of Spark, in which constraints play a crucial role. So it's very important to do schema inference even at the data lake level. And then, of course, you have schema evolution management. Your schemas changes over time, and you can use a schema inference technique to guide this management. Okay, so this is what I have planned to tell you about today. And of course, I'm here for questions if you have any.
Thank you very much, Dario.
Thank you very much, Dario. It was really interesting. So does anyone has any question?
Actually, hello?
Hello?
Can you hear me?
Hi?
Yes.
Yes.
Okay, basically I have a few questions. If you, first of all, thank you for your presentation.
If you can introduce yourself.
Yes, excuse me. My name is Raouf Mayata. I'm from University of USTHB, Houari Boumediene of Algeria. And actually, I found your presentation quite interesting. If you can allow me to ask some questions about it.
You're welcome. I'm here for that.
Okay. So basically, if you can go to the page 21.
Okay, so I have stopped sharing my screen, so I have to put it back. 21. Ah, 21. Okay, look, it's this one.
Yes, yes, this one. Actually, I have the approaches that you use to get the group of schemas, the schema from the data. You said here that it's in the L equivalence. It's based on the existence of the fields.
Yes.
Can you enumerate? Isn't there something that is based on the type of the field rather than the existence or not of a certain field?
Okay, good question. Actually, no. Essentially, in the sense that we limit ourselves to check equality in terms of field names, but we leave the possibility of having several different types for same field name. For instance, B here is can be either integer or string. And if I well understood, what you are suggesting is that you could make these stronger and say that you want the same type too. That could lead to another schema, of course.
Yes. Because
actually, as I've said before, there are many other possibilities. We had to fix a couple of approaches, and then, of course, you have several other possibilities.
Yes, thank you. And as a second question, is there something like a score when I know we're not in a meta-heuristic context, but in a meta-heuristic context we use what we call an objective function. it gives us an idea if we are doing good or bad or something like. Is there something like that in this context of the schema, of the JSON schema generation?
Can you please precise what do you mean? What do you have as input? What do you score actually? You have a schema.
Actually, the score is the schema aiming for something that I'm doing good or bad. Is basically you said one of the uses of the schema of JSON schema you are proposing is to load data in CSV files or using it in some queries. Is there some metric that I can use that says that my schema that I proposed is good or not good enough or very good, or to compare it with other schemas? Because we have several choices in this context, I can see.
Okay, thank you. Another interesting question. Actually, one thing that you could do is that you could say, I want to define my own schemas, right? Tell me whether I have well understood your use case or not. Don't hesitate to correct me. You could say, okay, I want to define my own schema, and then how can I estimate the quality of my schema? So one possibility is that you use our tool. You use our tool at the same time. You define your schema, and then you use our tool, and then you use a tool to check that our schema, for instance, is included in your schema. So in this case, you know that your schema really captures the totality of the data set.
Okay, I can see. So it's
so this is a possible way of scoring grading the quality of your schema, but you can do the other way around. So if you do the other way around, you are not sure that you are capturing the totality of the data set because you are included in our schema. Our schema is proved to be sound if once it's inferred, it meets the totality of the data. You don't ignore any piece of data.
Yeah, but actually, this answers quite my question. But that leads me to another one. You said that your solution was parametric. So if the solution was parametric, how can I compare two solutions based on the parameters that I chose?
Very interesting aspect. We worked on this aspect in the sense that so what would be interesting in order to answer your question is to have an algorithm to estimate the precision of your schema, how far your schema is from the data.
Yeah, actually.
And this has already been done for several schema languages, like for XML, for instance. There are approaches based on the edit instance or other notion of distance that can be applied. We have spent some effort in that direction. Then, since we have a lot of things more urgent to do, we have we stopped at the reasoning on that aspect. But this is very fascinating, and this is very complex. This is a very complex problem to be able to estimate numerically with a number how much far is your schema from the data. We don't have this.
I thank you very much for your.
We don't have this. We have spent some days, formalized something, but then we stopped it because we had some. We had a to-do list, and we prioritized essentially our work. But this is something that we couldn't explore, and it's very interesting aspect too.
Yes, it seems that you're doing a pretty good job so far. So.
Yes, we have. The field is very interesting. We would need 10 people to work in such aspect, but we have limited human energies. But if you want to work on this aspect, you are welcome, and then you can feel free to contact us if you want to collaborate.
Thank you.
Thank you very much, Raouf. Very interesting questions. I'd like to, so we're sorry we cannot really accept any more questions, but I'd really like to end with a very, very quick question for you, Professor Dario. So can you please tell me, that in a big data context, most of the times we talk a lot about the possibility of having faulty data and the possibility of having some inconsistent data, and that we should allow them to be there because we'd rather have big data than very precise and very correct data. So if you consider this aspect, in this case, if you are going to infer the schema from your data, maybe it's a good idea. You can tell me if it's true or not. Maybe it's a good idea to just ignore some of the data. So if I have, I don't know, 1,000 records that seem to be string records, and then only one of them is an integer, maybe I don't know if we can like have a threshold or something, and we can consider just the vast majority of the types rather than taking all the possible values and all the possible types. So what do you think about that? Do you think that this is
No, I think that this is a very important point. And actually, I have omitted in my presentation one of the several branches we have explored. We have a paper at the Database Programming Language Symposium showing how you can add the counting. Essentially, if you have a union, you can say, okay, 1% of the cases you have this field, 70% you have this field, and the remaining ones. So this kind of counting information could help a lot. But even without counting, if you detect that the field is a bit bizarre, is a bit strange, sometimes it's an empty array, sometimes it's null, sometimes it's an integer, sometimes it's a string. So this should attract your attention, and probably you could do some cleaning up for this field, or just ignore it because it's too strange and you are afraid that it's going to disturb your machine learning or your data processing.
Yes. Thank you.
So schemas could help in that direction, actually.
Okay. Thank you very much. So we thank you a lot for your presence and for your very interesting presentation. We'd like now to go to the second part of our meeting, which is the question answers about the different papers that we shared with you. So thank you for all the authors that were there and that shared with us their articles and their presentations. Thank you very much. You can find all the presentations in our conference website, but also in the YouTube playlist that we shared with you. So we'd like to introduce. So Fatma is sharing with us the playlist. So I'd like to see whether you have any questions. So any of you has any questions for the authors of the papers. So please introduce yourself and just tell us which article are you aiming and what's your question. So yeah, we can show very quick statistics about our conference in the meantime. So we had 25 submissions and accepted 12 articles. So most of them were from Tunisia, but we had returns from a lot of other countries. So 58% of the papers are long papers. 33% were short papers and 8% were posters, and we see that we have return from mainly Tunisia with 89%, but also from France, Germany, Algeria, Saudi Arabia, and Japan. So this is about our conference. So does anybody has any question for the authors? No one?
Okay, each author can present himself.
So yeah, so maybe the authors can present their work really quickly. Okay, I'm going to maybe to call the authors. Yes.
Hello, everybody.
Hello.
I'm Khawla Raboudi. Hello.
Hi.
Doctor in architectural science. So my question is for Alia Belqaid and Hassoumi, which proposes a French a paper written in French. Un générateur intelligent de circuits personnalisés pour une meilleure visite du patrimoine. Donc j'aimerais exprimer, exprimer en langue française, si c'est possible.
Oui, 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 bien sûr.
Et leur proposer la question suivante. Donc, en fait, je voudrais leur poser si, pour les mêmes contraintes, en fait, Alia et Inès, ils ont proposé un circuit personnalisé pour la visite de sites archéologiques à l'aide de systèmes multi-agents. Et donc, ma question, c'est si c'est pour les mêmes contraintes internes, telles que l'heure de l'ouverture, la fonction, etc., et externes, c'est-à-dire l'âge du visiteur, sa mobilité, est-ce que le système de génération de circuits de visite personnalisés va-t-il générer les mêmes circuits ou plutôt des circuits différents?
Donc, Alia nous dit que son micro est désactivé, qu'elle n'arrive pas à l'ouvrir. Alors, elle pourra, enfin, je lui ai répondu qu'elle pouvait répondre textuellement et que je vais lire sa réponse. En attendant, si Madame Inès Hassoumi a une réponse à votre question, elle est la bienvenue. Bonjour.
Bonjour tout le monde. Vous m'entendez bien? Je pense qu'il y a un petit écho.
Oui, là c'est bon.
Ah, d'accord, ok. Merci Khawla Raboudi pour cette question. Donc par rapport aux contraintes, vous dites que si on demande, on pose les mêmes contraintes au système, est-ce qu'il génère les mêmes circuits ou pas? Alors, comme notre système est basé sur les multi-agents, on a un agent responsable de la génération des circuits personnalisés, plus particulièrement un agent qui s'occupe de l'algorithme génétique. Comme cet algorithme génétique croise aléatoirement des segments de circuits qui répondent aux contraintes, par exemple, si on prend par exemple l'époque, la fonction, l'heure de démarrage de la visite. Donc, avec ces contraintes, l'agent va déduire des segments de circuits. Ensuite, avec l'algorithme génétique, il va les croiser. Ce croisement, généralement, il se fait de façon aléatoire. Donc, après ce croisement, on peut obtenir des segments de circuits différents en partant des mêmes contraintes. Donc ça, pour la partie AG. Ensuite, pour la partie personnalisation, en fait, notre système se base sur le profiling. Donc, pour chaque visiteur, on essaye, à partir des réseaux sociaux, on essaye de connaître ses préférences, ses centres d'intérêt, qu'est-ce qu'il aime, les restos qu'il visite. Donc, à partir de là, on va lui proposer des choses qui correspondent à ses centres d'intérêt sur le circuit. Donc, si deux visiteurs spécifient les mêmes contraintes, on peut obtenir des circuits différents selon leur centre d'intérêt qu'on a récolté à partir de leur profil Facebook ou autres réseaux sociaux. Donc, si je résume, avec les mêmes contraintes, notre système basé sur le scoring et le profiling génère des circuits différents pour rendre la visite encore plus personnalisée et encore plus proche des préférences des visiteurs. Voilà, je ne sais pas si Khawla a saisi ce que je voulais dire. Hein.
Oui, oui. Oui, oui, très bien, Inès. Merci.
Merci.
Merci beaucoup, Inès. Donc, Ali Abdelkaïd a aussi répondu. Donc, je vais vous lire rapidement ce qu'elle a écrit. Deux éléments vont aider le système à converger vers une solution optimale, le scoring et le profiling des données du visiteur. Comme l'algorithme génétique va chercher à s'approcher du circuit idéal, dont le but est de visiter le maximum de points de visite en un minimum de temps, après une sélection, il passera par des croisements et des mutations des segments de visite. Cette phase est aléatoire, donc le résultat peut changer d'une itération à une autre. Elle sera suivie par un scoring. Et d'autre part, le profiling des données de chaque visiteur va aider le système SMA à choisir le circuit qui se rapproche le mieux des préférences du visiteur, c'est-à-dire des préférences telles que ses hobbies, ses centres d'intérêt, des restos, des boutiques, des hôtels, etc., sur son itinéraire de visite ou de boutique. Voilà, merci à vous. Merci beaucoup pour vos réponses. Alors, est-ce que quelqu'un d'autre aurait une question?
Khaled Ahfaïd, il a une question aussi.
Oui.
Khaled, tu es là? Il va activer son micro.
Oui, allô?
Oui,
bonjour.
oui, on t'entend.
Oui, bonjour tout le monde. Alors,
bonjour.
je voudrais poser une question. Donc, je vais parler en anglais, d'accord? Parce que l'article a été rédigé en anglais. Donc, for a distributed intelligent agent-based intrusion detection system using deep learning algorithm. So my question is, so the idea here from what I understood is that this paper described the development of a distributed intelligent agent-based intrusion detection system using convolutional and recurrent neural networks for the training and attack prevention, right? And the proposed system is composed of 5 principal agents, so collector agent, configuration agent, 2 training agents, CNN and RNN, and finally an analyzer agent. Is it right?
Yes.
Yeah. Okay. So my question here is, it's not clear. I didn't already understand how the algorithm, like, so we have here the distribution intelligent agent using these agents, and we have an algorithm that describes how the agent communicates. So I would like to have an idea, like how the agents really communicate to coordinate the common goal of training and attack prevention. Like, because I didn't see any algorithm that describes really how it really works. Like, how do they coordinate this work? Do they have is it in sequence? Is it in parallel? Like, is it like achieved in a specific way, or?
No, it's not in a specific way. First of all, thank you for your question. Then I think I'm going to express myself in French, like you can do also. Like it's better. Bon, pour la communication, je crois plutôt pour un premier projet que c'est fait d'une façon séquentielle, tout à fait normal. Tout d'abord, c'est l'agent qui fait ce qu'on appelle qui traite les données avant de traiter dans les réseaux de neurones, se fait de façon séquentielle. Le premier agent, après avoir saisi les données et les avoir traitées, c'est juste des messages de notification où il informe les prochains agents qu'il a fini le traitement des données. Donc, c'est là où la simulation va commencer. Les deux réseaux convolutionnels ainsi que le récurrent vont commencer l'apprentissage pour enfin générer les modèles pour l'analyseur qui va comparer entre les deux modèles afin de choisir le meilleur pour prédire les attaques. Voilà. J'espère que la réponse a été claire. Y a-t-il une autre question?
Oui, merci beaucoup, oui. Alors, maintenant, quand vous parlez du loss, the proposed analyzer, like la perte,
oui.
au modèle généré, donc vous générez des modèles et il y a une certaine perte par le CNN et le RNN, c'est bien ça?
Oui, bien sûr, oui.
Est-ce que vous avez une idée d'autres, par exemple, d'autres modèles ayant été proposés et qui ont, par exemple, un certain aussi résultat à qui on peut comparer, par exemple, vous avez parlé à un certain moment de ce qu'on appelle l'approche mobility.
Yes,
Ou est-ce
yes.
est-ce qu'il y a-t-il une comparaison, ça veut dire par rapport à la performance avec votre, par exemple, y a-t-il déjà d'autres modèles avec de l'approche mobility et y a-t-il une comparaison qu'on peut avoir par rapport à quelques, par exemple, outcomes ou quelques résultats?
Désolé, j'ai pas bien compris la question. Bon, quand vous parlez de mobilité, c'est une fonctionnalité qu'on trouve dans les systèmes de multi-agents. C'est pas une approche. En général, dans les systèmes de détection d'intrusion, quand on parle d'approche, il y a deux approches. On parle de l'approche par signature ainsi que l'approche comportementale. Donc, ici, dans mon travail, nous nous sommes concentrés surtout sur l'approche comportementale. La mobilité des agents, c'est une fonctionnalité qu'on peut travailler sur et qu'on va travailler sur, hein. C'est parmi en anglais, on dit purposes. C'est parmi nos buts dans les prochains travaux de travailler sur la mobilité dans le réseau. Voilà.
Donc, c'est une fonctionnalité que vous pouvez ajouter à votre.
Il y a toute fonctionnalité qu'on peut ajouter au projet. Voilà.
Ouais, mais il y a d'autres, ça veut dire il y a d'autres. Ouais, ben merci pour la réponse. Donc,
Merci.
oui. Donc, je vais poser une autre réponse, pardon, une autre question rapidement. Donc, par rapport au false negative rate, ou
Yes. Les taux de faux positifs.
voilà, ouais, je connais pas trop les termes en français, mais
Voilà.
ici, donc, vous, d'après ce que j'ai compris, donc votre système distribué, il est supposé améliorer la précision et
Le taux de détection ainsi que diminuer le taux de faux positifs.
voilà, diminuer le taux. Oui.
Voilà.
Et est-ce que vous pouvez considérer à travers votre étude que vous avez pu vraiment diminuer ce taux?
Bon,
Parce que
bien
c'est pas
sûr,
que. Oui, oui, oui.
bon, comment je vais répondre? Bien sûr, comme vous voyez dans les figures que j'ai mis dans la
Mhm,
présentation, les fonctions de perte représentent le taux de détection. Voilà. Lorsque
mhm,
les pertes sont diminuées, le taux de faux positifs, ça représente le taux des faux positifs qui, proportionnellement, sont diminués. Bon, je n'ai pas trouvé la meilleure expression pour la réponse, mais j'espère que
ouais,
j'ai
donc est-ce que vous considérez que par rapport à ce
le taux de,
métrique,
le,
un des métriques les plus importants, donc vous avez pu vraiment diminuer
le
cette
taux de-
false, oui.
Bon, l'apprentissage s'est fait sur sur la base des NSL KDD euh, que vous avez vu. Je pense que vous avez vu dans la présentation. J'ai présenté la base d'apprentissage sur l'NSL KDD. Il y a d'autres bases d'apprentissage où il y a beaucoup d'autres de simulation des attaques.
Mhm,
Bon, parmi les buts des travaux futurs, on va travailler sur d'autres bases qui sont plus récentes avec les attaques les plus récentes. Euh, et je pense que en appliquant le système et les algorithmes, on peut quand même faire diminuer de façon bien meilleure les métriques proposées telles que le taux de faux positif ainsi que
mhm.
augmenter le taux le taux de détection. Voilà.
Ok, merci beaucoup à
Merci.
vous. Donc, je vais passer maintenant à un deuxième article, si je peux, Fatma, et si c'est possible de poser des
Oui,
questions
oui,
par rapport
merci, Fahd, oui.
Oui, alors, so I will be asking few questions regarding the article entitled "A Multimodal Biometric Identification System Based on ECG and PPG Signals." So from what I understood here, this paper described the development of a multimodal biometric identification system based on two physiological signals. So electrocardiogram, which called ECG, right? And photoplethysmogram, which is called PPG. So they use a combination of two types of deep neural networks, so convolutional neural networks, CNN, and again, and recurrent neural networks, RNN. So my question is regarding the BS especially. So from what I understood here, you have shown the results that we have a better average accuracy of 94% with the multimodal system having the GRU cell for the RNN network, which outperformed the formal biometric systems, right? And so I don't know if the authors can hear me well. Okay, so my question here is about the limitations. So you have mentioned that there are some kind of limitations, especially the one related to the bias, such as the size of the database in terms of number of subjects and the duration of the recorder signal, which have been highlighted. So this could affect the results significantly. So can you tell us how much and what's the impact of this bias?
Khalid, I'm sorry, but I think that the authors are not here.
Okay.
So I'm really sorry. Thank you very much for your question, but I guess nobody will be able to answer you. So.
Merci beaucoup, Khalid. Thank you very much.
Thank you, Khalid. Merci beaucoup. Do you have any questions? We can still afford one other question, and then we can.
Zeki aussi a une question. Zeki.
Sorry.
Zeki.
Bonjour. Oui. Bonjour.
Bonjour.
Ma
question c'est pour Makram Janedi. Je vais parler en français. Ma question c'est l'idée générale du papier, c'est de faire du groupement des CV, étant des CV qui sont un peu hétérogènes, etc. Ma question c'est au niveau pourquoi vous faites le regroupement et pas la classification. Pourquoi ne pas opter à utiliser le classification au lieu du regroupement? Ma deuxième question, c'est au niveau de l'aspect sémantique dans les attributs qui existent dans le CV. Parce que un mot peut changer l'attribut que vous utilisez pour le regroupement. C'est ça en fait mes deux questions. Ma troisième, c'est au niveau, est-ce que vous avez comparé avec des bases de tests, le passage à l'échelle par exemple, parce que dans le papier, je n'ai pas trouvé une comparaison avec d'autres algorithmes ou d'autres approches, si vous voulez, qui traitent la même problématique. Voilà, c'est mes trois questions en fait pour Makram.
Donc je me présente, Makram Janedi. Alors, concernant la première question, pourquoi on a fait du clustering et pas de la classification. En fait, notre but est de créer, de manière plutôt générer quelques groupes de candidates, c'est-à-dire générer des classes. Donc, c'est un problème de clustering plutôt que de classification. Donc, on a opté à cette méthode, vu les données qu'on a regroupées, voilà, qu'on a extraites de la base de la CV, de la base des CV.
Concernant Makram, juste une question ici. Étant donné que la société ou l'entreprise d'une manière générale a un objectif, en fait, faire le regroupement, un objectif donné, pourquoi ne pas fixer mes classes avec les attributs que je cherche, suivant l'objectif de l'entreprise, et du coup, je suis dans un problème de classification. Peut-être c'était ça l'objectif de ma question. C'est-à-dire, suivant les besoins de l'entreprise, je crée mes classes avec les attributs nécessaires et maintenant je passe à un problème de classification.
D'accord. Donc, à Wavio, on avait deux besoins. Le premier besoin, c'est celui que vous venez de le décrire, c'est la classification. Donc, on a créé 9 classes. On a défini chaque classe, par exemple, une classe de, par exemple, front-end, quelles sont les technologies nécessaires avec des pondérations et ainsi de suite. Et on a, et puis on a classé les candidates en 9 classes qu'on a créées. Et puis le second besoin, c'est de générer des groupes en tenant compte de toutes les informations qu'on a. Le but, finalement, est si je choisis un élément que j'apprécie ou que j'apprécie pas, je veux avoir les personnes ou bien les candidats qui sont similaires à cette personne-là pour, pour optimiser la recherche peut-être. Et donc, pour ce second besoin, on a opté à un algorithme un clustering plutôt que de classification. Donc, on a déjà répondu au premier besoin.
Okay.
Pour votre seconde question, je n'ai pas pu l'entendre. Est-ce que vous pouvez la répéter?
C'est au niveau de la sémantique, c'est-à-dire, comme tu sais, donc vous avez des CV, les attributs dans les CV peut-être changent. Sémantiquement, c'est kiff-kiff, c'est similaire, mais les attributs, point de vue, le mot ou l'expression, c'est différent. Est-ce que vous avez pensé à inclure un module afin de prendre en compte ces aspects sémantiques dans les attributs qui décrivent les CV? Je ne sais pas si vous avez compris ma question.
En fait, j'ai pas bien. Bon, pour la catégorisation des variables entre variables continues ou bien catégoriques, c'est ça votre question. Donc, c'est pourquoi qu'on a choisi d'utiliser K-prototypes qui peut fonctionner avec les deux types de variables. Donc, les variables catégoriques où les labels sont plutôt des champs et les variables continues. Et donc, on a utilisé K-prototypes pour cette raison-là.
OK. OK.
OK, merci.
La troisième, c'est au niveau le passage à l'échelle. Est-ce que vous comparez la solution que vous avez utilisée? Et ceci m'amène à la question du choix en fait de l'algorithme que vous avez utilisé pour faire le regroupement, plutôt le clustering. Est-ce que vous avez comparé les algorithmes et la question de passage à l'échelle, c'est-à-dire la base de données que vous avez, la base de test que vous avez utilisée. Est-ce que vous pouvez nous donner des informations sur cette base de test que vous avez utilisée, point de vue nombre des CV que vous avez traités, nombre des attributs ou des features que vous avez utilisés? Est-ce que vous pouvez nous donner une information sur tout ce qui est autour de l'expérimentation? La taille et la comparaison.
D'accord. Concernant la comparaison, on a essayé un algorithme, un pipeline d'algorithmes, c'est de faire l'encoding des variables, des variables catégoriques qui a généré un ensemble de variables qu'on appelle dummy variables. Et puis utiliser ACP, l'analyse en composante principale, pour réduire la dimensionnalité. Ensuite, utiliser K-means qui ne traite que les variables continues. Donc, le résultat n'est pas vraiment intéressant parce que, et c'est déjà décrit dans l'un des articles de Huang qui a proposé K-prototypes. Donc, ça n'a pas donné des résultats intéressants. Donc, il ne faut pas encoder les variables parce que les variables catégoriques qu'on a peuvent avoir des centaines de labels, de catégories. On a aussi implémenté quelques algorithmes, aussi quelques autres idées avec Word to Vec pour créer des dictionnaires de skills. Donc, c'est la même étape que K-Prototypes peut la faire. Ensuite, on a essayé cette méthode en 2 étapes, K-Mods puis K-Prototypes. Concernant la taille des données, on a extrait presque 20 000 de CV et en évaluant voilà, concernant le nombre de variables après l'étape de flattening dataset, c'est presque 2000 variables, 2000 skills différents. Concernant l'échelle, pour le scaling, si on reçoit d'autres CV, donc c'est l'une des choses qu'on va tester prochainement. On a collecté 40 000 autres CV, donc, et on va l'essayer.
Ok, merci. C'est tout, Fatma.
Merci beaucoup, Zaki. En fait, Monsieur Orb Kazar a dit que les CV sont établis par rapport au poste concerné. Ne faut-il pas penser à l'utilisation de la logique flow et le principe de l'adaptabilité?
Pardon?
Alors, il y a le message de professeur Orb Kazar qui vous demande, alors, les CV sont établis par rapport au poste concerné. Ne faut-il pas penser à l'utilisation de la logique flow et le principe de l'adaptabilité?
Honnêtement, je n'ai pas compris la question, mais on a collecté les CV pas uniquement à partir des offres, mais on a fait quelques... on a aussi utilisé le web. Donc, les CV sont un peu pour tous les postes. Donc, pas uniquement les CV qu'on a collectés par le service RH, à travers le service RH. Donc, une vue plus ou moins globale, parce qu'on a aussi utilisé le web.
Très bien, je vous remercie. Alors, Madame Alia Falqaïd, donc je pense que ça va être la dernière question pour aujourd'hui. Pardon?
Est-ce que je peux intervenir?
Oui, allez-y.
Alors, tout d'abord, je tiens à remercier donc les collègues organisateurs de ce track.
Merci.
Apparemment, pour le moment, je suis le seul de l'Algérie, peut-être. Je ne sais pas s'il y a d'autres.
Non, il y a Raouf Maya.
Oui.
Ah oui, d'accord, oui. Et puis, donc, j'ai bien apprécié, donc... Ah oui, Raouf, oui. J'ai bien apprécié aussi la présentation de notre collègue, donc je pense que c'est une très bonne thématique. Et aussi, donc, les papiers qui ont été traités dans ce track. Bon, j'avais des questions aussi sur des aspects agents que notre collègue a introduits tout à l'heure, mais peut-être je vais rapidement donc parler avant de revenir à la question que je viens de citer. Donc, généralement, les agents sont utilisés pour résoudre un problème qui nécessite une coopération. Et beaucoup de chercheurs actuellement donc, se laissent aller vers le désir donc, d'utiliser les systèmes multi-agents sans toutefois donc, motiver l'utilisation de ce paradigme. Malgré que notre collègue qui a parlé tout à l'heure, elle a très bien justifié l'utilisation du paradigme agent. Alors, je reviens rapidement à la question du profil CV. Moi, je pars d'une petite expérience. Et un CV, généralement, il a un objectif de savoir se vendre. Donc, si je mets un CV, c'est pour me vendre et pour que le demandeur d'un client, moi je suis le client ou bien le demandeur du poste, accepte ma proposition, c'est-à-dire mon profil via mon CV. Pourquoi j'ai dit l'utilisation de la logique floue? Parce que dans un CV, on peut décrire des compétences ou bien des descriptions de l'individu ou de la personne sous forme de paramètres. Je suis très bon, je suis très faible, je suis fort, j'ai beaucoup travaillé, j'ai faiblement travaillé, j'ai une grande expérience, j'ai J'ai enseigné pendant 10 ans, pendant 5 ans, et ces valeurs textuelles peuvent être présentées sous forme de logique floue. D'ailleurs, même des plateformes de recrutement, ils mettent des choix. Vous avez combien d'années? Beaucoup plusieurs années, peu d'années, une année. Vous n'avez pas exercé une fonction. Et ces paramètres-là, à l'intérieur de la plateforme ou le back-end, sont décrits par des valeurs floues. Ils ne sont pas décrits par des valeurs continues. Et l'adaptabilité, bon, moi j'ai dit ça, l'adaptabilité, parce que nous avons tous un profil méta ou un profil méga qui décrit tout notre parcours dans un secteur, dans une université ou une industrie. Mais par rapport à un poste donné, on essaye d'extraire ce qui est important par rapport à un appel d'offres ou un job quelconque cité pour être recruté. C'est pour ça que j'ai dit, peut-être dans les futurs travaux que vous allez développer, réfléchir peut-être à utiliser cet aspect de flow qui permet de représenter les valeurs linguistiques et l'adaptabilité d'un profil, c'est-à-dire l'extraction de ce qui est très important dans un profil large par rapport à un poste donné. Et c'est très important parce que nous-mêmes, quand moi j'ai par exemple mon CV qui est très large, par exemple, et quand je vois un poste, par exemple, de travail en Belgique, je dois extraire de ce CV ce qui est important par rapport à ce poste. Si je vois un autre poste en Arabie Saoudite, je dois extraire par rapport à ce poste ce qui est très important pour que je puisse être accepté. Voilà donc un petit peu ma réflexion que j'ai faite à cet instant. Et je vous remercie pour cette présentation. Voilà, je vous rends la parole.
Merci.
Merci beaucoup, Monsieur Orba. Donc, bon, je suis vraiment désolée, mais on va devoir clôturer la session. Donc, je passe la parole à Madame Fatma, qui est là avec nous.
Merci. Donc, je tiens à tous à vous remercier. Merci beaucoup. Donc, je remercie Guy pour sa collaboration. Merci à Dario Colazzo d'avoir pour sa présentation. Thank you very much. Et donc, honoré, donc, Monsieur Orba, tu nous honores par ta présence aussi. Merci beaucoup. Je suis très contente d'avoir des retours de plusieurs disciplines sur tout ce qui est intelligence artificielle et big data. Et ça sera une idée pour créer une communauté modeste, bien sûr, mais petit à petit, on pourra former une communauté où on pourra avoir toujours des actualités. Donc, je pense vraiment pour des perspectives pour les prochaines éditions. Donc, j'espère que vous allez toujours être avec nous, toujours à jour et toujours présent. Merci beaucoup.